Hi guys, welcome to Real Time Signals. Python has a unique culture and community based on its core design philosophy of readability and syntax that enables us to write a concise program. In this course, I will provide you an overview of design philosophy of Python. I'll show you how to install Python on your system. I'll also show you how to write basic Python program with built-in data types, loops, conditions, etc. So let's get started. Let's take a look at Python feature. Python is open source, which means it's free to obtain, modify, use for any purpose and redistribute. It's quick to learn, which means you get to speed programming very rapidly. It's easy to understand and which makes it easy to maintain your program over the time. It's very powerful with many different modules provided for lots of capability, and you will find it useful for many programming domains. As far as Python technical feature is concerned, it is an object-oriented language, although you can use it for procedural and functional programming as well. Variables are dynamically typed and given their type at the assignment, as opposed to with other static languages. It's strongly typed because once object has its type, that determines whether the function can be used or not with that object. In loosely typed language, its object can be covered to perform functions where its type normally not allowed. It's white space delimited. Instead of using keywords or braces to delimit block of code, Python uses indentation, where typical forward space are used to adapt each block of code. It's interpreted, which means you may take it time and maybe it is slower than compiler, but it allows the programmer to interact directly with the interpreter and inspect the code object without having to recompile. Python comes in many different editions. CPython is standard type, where Python is implemented in the C programming language. JPython is implemented with Java Virtual Machine, which allows the programmer to blend Python in Java library. IronPython is for Windows, which implements common language runtime, and it also allows of mixing .NET assembly in Python. And PyPy is Python implemented in Python. It is having just-in-time compiler. It's one of the fastest edition, like the other non-standard editions. It provides solution for some of the weaknesses over CPython. As far as Python ambiguity, you'll find it everywhere. It's very popular in the web, where major frameworks such as Django and SOAP allowing for easy creation and management of websites. It's Blender project, which allows creation, manipulation, animation of 3D models. And its desktop application is not only to write plugins or to do advanced programming such as GIMP or Photoshop, but also to create applications like Dropbox. You don't think you can't have fun with Python? You got to check out Pygame project. This framework provides the ability to use animation, music, sounds, devices within to create a game. Python is also very popular with scientific community through packages such as NumPy, SciPy, providing advanced mathematical functions. It's important to understand there isn't one Python version. There are two main current Python versions. There is a 2.7.9 and 3.4.3 available at this time of writing. Although it seems like a small difference, but it's a significant. Python 2 is currently in use. However, it will be moved into maintenance mode after 2.7.x. Some of the updates from 3.x have been ported to 2.7. Beware, if you write a code in 2.7, it is not fully compatible with Python 3. Python 3 is intentionally broke backward compatibility with Python 2 in order to make things better. Most modules now have been updated in Python 3. You should be using Python 3 by default for any new project you start. Reason to use Python 3. From python.org website, it basically explains Python 2.x is a legacy and Python 3 is present and future of the language. So unless you use a module from Python 2 that has not been updated to Python 3, you should be using Python 3. This course uses Python 3, but we will mention wherever there is a difference in Python 2. I am going to show you how to install Python on Windows, although same steps are valid for other operating systems. If you want to install Python, go to website www.python.org/downloads/. From here, you can download Python 3.7. You can look for precise versions as well here. You can also find source code of Python. You can look for community, documentation, success stories, news, as well as Python Advanced. On my desktop, I have already downloaded the setup file. If I double click on this, it will begin the installer. Let me click on run. You can go for, you will have two choices, or you can go for a customized installation. I will say the full Python. It will ask me, because I have admin rights, it will ask me this question. But if you are not having admin right, it may ask you a different question. Now it is installing. After some time, you can find a window like this which says setup was successful. I close on this. Now I can find a new Python 3.7 on my Windows machine. Depending on your version of Windows, you can choose to look for Python Here I type Python and I can see Python idle of 3.7. I click on it. You can see Python shell. You can open a new file where you can write your source code and you are ready to go for Python. In this video, I'm going to talk about Integrated Development Environment IDE. Although you can use simple text editor and there are many advanced IDE available. Python does come with advanced IDE or idle by default, which can get you started. To start the icon, it will typically take you to Python idle. When you click on it, you will see Python shell. Here you can type various statements. For example, here, or you can also open your recent files. Once you open a file in the editor, you can see comments in red, string in green. The keywords will be in orange. Any definition will be in blue. And the built-in function will be in purple. You can see similar colors here on your shell as well. And you can find errors right away. When you start working with Python, you need to understand that Python uses whitespace to create block of code or to define what we call code suite. I understand at this point we don't understand any of these codes, but you can see using a class here statements that are part of the class will be indented with 4 white space. Likewise, when defining a function, the statement that are formed a function will be indented. When we use if, elif, else type statements, the block of code that execute either if it is true or false will be indented. Using for loops, while loops also as indented statements. Now you can notice before your indented statement starts, you have a column. You will notice that when you work on Python shell, it might be awkward at times, particularly else classes as part of it. For example, if I type an if class and when I hit enter, the automatic indented statement will be created and I can type my code here. I will type it again. It remains indented, you can see, as long as I don't press a backspace. So now if I press a backspace, it will take me out of this class, or I can start the other class. So I hit enter and backspace, I can start the other class else. Here as well, after I hit column, enter, it will go automatic indent. It remains there as long as I don't hit the backspace. So I hit enter, and if I hit one more time enter, this code will get executed. You can see if it is true, this class of if is getting through and the statement underneath are executed. When I'm all done with executing if and else block or suite of code, I can have the blank line. I can use arrow keyword, go back to the previous code. It will bring me back to the previous code. When I go to the top of the code and enter, here I can use my arrow key to move and to change the code. For example, here I change the logic in reverse direction. Come back and I press enter, enter. Now the other statement of else got executed.
As a piece of advice, I recommend not to use tab because in order to create blocks, we have to use white space or white space. So don't use tabs or don't mix them. Always use white space in Python.
One of the benefits of working in Python programming language is the ability to interact with Python shell with the given Python interpreter. Some people consider this as a read, evaluate, print loop repeated over and over. For example, I might type in print output on the Python shell. When I hit enter, it read the code, evaluate and print and ready to do it all over again. So it's waiting for me to provide another command now. Sometimes it is required to keep typing more than one line in order for to know to evaluate. For example, if we start a block of code, something like for example for loop in range 6 colon. Here when I type colon, Python knows that there is going to be a suite or block of code. In this case, the first statement in there, I'm going to print index. And I complete this suite of code by pressing enter. Then it prints out the result and loops back and get ready to start all over again. There can be even commands that dir parenthesis, which is dir function that could operate, and then Python evaluate, print out the object in current namespace and get back again to take your input commands. If you want to user to control over your program, then you can receive input from them. If you want to do that, you can use input function. In Python, this is an inbuilt function. To find more about inbuilt function, you can type help parenthesis and then the function name. So in this case, it gives you documentation of input function. Here you can see the prompt and you can say equal to none. You can see the documentation. It says read a string from standard input and stripe the trailing new line. You can see the parameters are optional. Let's take a look how to use it. For user to give their name, we can create a variable by name and use function input single quote. What is your name? Question mark. I leave a space here so that user cursor can be separated from the string here. Let's execute. It prints the name, what's your name, and I can give my name. Now if you want to see what's there in your string, in your variable name, you can inspect and it says my name. If you want to output your username, you can't simply write the variable name. You have to use function print. So here I use function print hello space name. So it prints my name with hello. Now if you want to put additional information, for example welcome to Python, then we can do it by providing additional value or by string concatenation. For example, here I'm going to add welcome to Python as greeting. So you can see that just by comma separating I can provide additional information. One more thing, you can see that when I put a comma, automatically it takes a white space. I can combine two strings also. For example, here I use plus where I don't use comma now, and I do the same thing, welcome to Python. So here you can see I didn't put a comma and I created a space as well. It serves the same purpose. Now that we have a working code, we can create a new file where it will take input from user. So we copy the code which takes input from user, and then it prints username with a greeting. I copy paste two of these lines, and then I can save them by a name, say user underscore input dot py. Now I can run this module, run module, and here it's waiting for my input, and I provide my input and printing my name with the greeting. Now we have full code which takes input from user and prints the output. Learning how to use module is central part of Python. Any Python file ending with .py can be called as Python module. You will also sometimes find modules that are compiled with .pyc or .pyo file as well. In this example, as you can see in your screen, I have prepared a Python demo file that demonstrate multiple methods to import modules and their other data attributes and functions. The most basic form of import is to use import and module name. For example, here I have import math, and then you'll be able to use the data attributes of it. For example, here I am using data attribute as .py and function as .10. And in this example, you'll find dir. Dir is an inbuilt function which will print the list of the namespace you have. By default, if you don't specify the namespace, it will be creating underscore underscore main underscore underscore as your namespace. I'm going to run this module and see what's going to be my output. Let me adjust the screen a little bit just to show you the proper format and nice font size. So now you can see my output. It says the list of main namespace, and it prints the object's names in the main namespace. You would notice that before before importing math, it didn't have math as one of the object, but once I did import math, it became part of main namespace. Now after this, you can see I got my value of pi as the data attribute, and the function tangent 10 gave me an output of 1, 10 of 1. Let me go back to my code again. Now the math name is deleted here, and then the second part of my code starts. In this second example, the name of math is alias to fun. You can see here. So we will import the math module as fun, and we will look at the main namespace. It's going to have fun instead of math, and we will access attributes like fun.py, fun.tan, and you can see once I am done with this, I'm deleting the fun. So you can see the output of my second example. The list of the main namespace, by default it came back to the same thing because I deleted math, and now once I add fun as an alias of math, it is showing as fun, and I could access the data attribute pi and function tan. Now let me go to a third way of working with names. So we can do selectively. Things like attribute, data attribute or function, we can directly put into main space as this command from math import pi and tan. You will see the output from the shell that these names pi and tan are getting added into main namespace, and we can directly call the name now pi instead of writing math.py or fun.py. We can directly call them as pi and tan. Once we are done with this, we'll delete pi and tan from our main namespace. Let's look at the output. So here you can check the third example. Starts from here. Before importing pi and tan as the names from math module, it was default values and then got added, and we got the same value of pi and tan. Now come to the fourth way of importing modules. Here, to avoid you may have your names in your namespace pi or tan. In this example I don't have though, but it is possible that in your available file you may have something of a similar name. So you can use aliasing like we did before for the entire module. You can do aliasing selectively. So next example here, you can see the pi is aliased as pi with e. The function tan is aliased with tangent as it spells out. So we can see that listing. Now we can go back to our shell output. For the fourth example, you can see that the new names pi and tangent are added into the main namespace, and the values are exactly the same as we were getting before. Now there is one more way. Sometimes people are using it. It is to use a wildcard. In this last example, you can see the math module import with asterisk, which pollutes, as they say, a namespace. Every namespace that is defined in this module will appear in the main namespace. You can see a long list of all these different names on your Python shell. You can see here acos, acosh, assign, pi, tam, whatnot. Particularly if you didn't write this module, it's not a good idea to import with a wildcard. Knowing how those names could actually ends up overwriting your names or certain things which you didn't expect. So you should avoid using wildcard import. You might be exporting your shell. So now that you have seen different ways of doing this import of modules, their data attributes and their function, let's create a module of our own. So I will go click a new file. We'll take advantage from that pi of math module. Now since pi is not likely to be defined in our main namespace, the only thing we are going to need in this example, so I'm not going to do alias, we might just say from math import pi. We'll use again the input function that was previously discussed to obtain some information from our user. For example, in our case, we will get the radius of our circle by prompting the user. So let's write radius equal input what is the radius of circle. This mark white space and then enter. Now the result is radius is going to be string. we need to convert the string into a float value. Let me do a print the area of circle is float is an inbuilt function of Python, which is to convert string to a float value. So radius, which is right now string, converted into float, and operator star star is to do power of 2 and then say pi. So that's going to be your area of circle, which is pi r square. Let me save this file. And I save it as circle demo.py. Let me run the code. It's asking for radius 5 and the area of the circle is this value. So now that we have learned how to import a module, their attribute, data attribute, their functions, and perform some arithmetic on it. If you want to write your first program, it is often called Hello World. In Python, it is a single statement. We will experiment this statement on Python shell window to make it work. Then we will copy that code and paste it into our source code file where it could be used repeatedly. So in this Python shell window on my screen, I will type print, which is the name of the function, and parenthesis. Now you can see the parameters it can take separated by commas. We have to provide only the value, which is in our case string, of the text we want to print. So this case, for this program to work, we will type print, we'll type quote hello world exclamation quote and close the parenthesis. To execute this, I just enter and Python shows me hello world. Now that we know that this code works, we can copy the text by using Ctrl+C and we create a new file and we paste our code. Before we run this code, we need to save this file. You can say save as, Here I'm going to create a new folder, my script. Then I'm going to type the file name. My file name can start with letter or underscore, and it contains letter or underscore, sometimes numbers. Possibly use lowercase all the time, and extension should be .py. I save this file. Now this code is ready to execute. I use run module. Now you can see Python shell restarted, and we see our output as hello world. Congratulations, we just created our first Python program. Let's talk about the integer type in Python. As you can see on my Python shell, variable x is assigned with a value 5. Now I can see the type class by using type function of x. It is int. Basically, in Python 3 you no longer have long type. The long type used to be there in Python 2. In Python 2 we had both integer as well as long type. There is no distinction any longer in Python 3. On the right side of my screen you see a file as int_demo, and you can see assignments like x equal to 5, y equal to 10, which would also give int type. What you would not expect a 0x prefix, but this means that the value, it is hexadecimal, although the value will be stored as integer in that variable y. Likewise, you can use O0 prefix if you want to use an octal value. In Python 2, you can use a 0 prefix in front of a number to indicate an octal value. 0b is used for binary, and in all these cases values are same as decimal with base 10. And we can see if we go run this program, let me run the program. The first thing is x equal to 5, y equal to 10, where that binary value is actually representing 10 internally in Python. You can also see that you can use typical comparison operators in Python like double equal, exclamation equal, which is not equal, double equal, which looks for equality, not equal, look for inequality. We have greater than equal, greater than, less than equal, less than, and each of these values, each of these cases, you can see that there is a boolean true or false which is getting returned from these operators. You can also use that typical operator as you would expect for plus, minus, asterisk, forward slash, plus for addition, minus for subtraction, asterisk for multiplication, forward slash for division. Something here in the division, it's different in Python 3. The division will yield a floating point number rather than a floor division, which was the case in Python 2. Do you want to force a floor, then use double forward slash, and this will always give you an integer divisor. You can use a percent operator, module operator as a module or the remainder after division, or double asterisk. You can use it for power. So here in this case, x raised to power y, which is here. So there are several built-in functions. You can always find them useful, like div mode, which will return a tuple with the divisor and the remainder. You also have a power function which raise the value of x to the y, an absolute value function which will always returns a magnitude or a positive value, the integer function which converts basically any floating value to integer value. It will even do that different bases like base of 16. If you want to convert integer to a floating point number, then you can use a float function. As far as inline operators are concerned, you can do, it doesn't support plus plus or minus minus, but you can do plus equal, which is equivalent of x equal to x plus y, minus equal, which is equivalent to x equal to x minus y. Similarly, you can do x asterisk equal y, x forward slash equal y, and you can see these results here on the left side on my Python shell. So if you want to assign multiple variable in a single statement, you can use, for example, x comma y equals 4 comma 2, and it turned out that it becomes x equal to 5, y equal to 2. Finally, we might want to mention about bitwise operators that can be used in Python. For example, bitwise OR, exclusive OR, bitwise AND, left shift, bit, right shift, bit, or inversion. We have these symbols or operators that can be used to perform these operations. This was the brief introduction of integer type. I hope you find it useful.
Let's discuss Python float type. If you assign a value with a decimal point included, for example here x equal to 5.0, then Python automatically will directly assign to a float type. Let me show you. Yeah. Let's discuss more the float type based on my example here called float underscore demo. The float type is very similar to int, but uh, when you are doing an assignment, you are going to do include a decimal point. For example, here it's 5.0. You can also do assignment with a float clause from hex. Here the hexadecimal value of a is converted into float. And in this case, if you see, you're not doing any special prefix of 0x, simply writing a. Let's run this program and see what's the output. So I run this program. Here you can see my y value, which is from hex convert using method called from hex. A, which is 10, is converted into 10.0. The decimal value of a is 10, so it is converted here. Now there is another function called integer ratio, which just show the ratio. For example, here the value 5 is represented as 5:1. It also has a method called hex. You can see y.hex here, which represents your float value into hexadecimal, like the integer we had. It also supports the basic comparisons, the typical comparisons, what we had seen in integer, similar to that. Example here, equality, inequality, greater than, equal to, less than, same as what we had seen in integer type. It also supports the basic usual operators like plus is for addition, minus, asterisk for multiplication, division, and all of that we have seen it in integer type. It also supports the basic built-in functions, what we had seen in integer type, similar to here. One thing which is noticeable is it is using an inbuilt int, which converts your floating point number into an integer value. So here you can see the value which was 5.0 doesn't have that .o. Similar to integer, you have a inbuilt function float. So the value 10 is an integer value. Here it gets converted into 10.o. It supports inline notations to do something like x plus equal to y or x minus equal to y. It also supports the multiple assignments where the values to variables can be assigned values with comma separated. So here you can see x is equal to 4, y is equal to 2.o. Bitwise operators are not supported in float type, although they were be used in integer type, but here it's not supported in float type. One last word I would leave you about float point is it is subject to rounding error. If you want to use a type that is more accurate without rounding error, then you might want to consider a method called decimal module.